this lecture, we're going to look at double replacement reactions. Double replacement reactions, they have this general format. You start with two compounds and you expect two compounds as products. Now, let's look at the reaction of lead-2 nitrate and potassium iodide, and I'll show you how we can predict the products of a double replacement reaction. So, in the aqueous solution of lead-2 nitrate and potassium iodide, we expect ions. So, let's write the ions we expect from these solutions. So, in the solution of lead-2 nitrate, we would expect lead-2 ions and nitrate ions. In the potassium iodide solution, we expect potassium ions and iodide ions. Now, in a double replacement reaction, we're going to swap the cations and anions, meaning the cation of our first compound, which is lead-2 nitrate, is going to combine with the anion of potassium iodide, and the cation of potassium iodide is going to combine with the anion of the lead-2 nitrate. That means the products we expect to get are going to be lead-2 iodide, which is insoluble in water, and potassium nitrate. Now, this reaction is complete. We also have to make sure that the reaction is balanced. So we're just going to identify what the cations and anions are, and we're just going to exchange the cations and anions, basically swap the cations and anions. Now, let's look at another example. So there are different types of double replacement reactions. One type is the neutralization reaction. Neutralization reactions are when an acid reacts with a base and you would expect salt and water to form. Now, neutralization reactions are exothermic reactions. So when the acid reacts with the base, you would expect heat to be produced. Now, let's look at the reaction of hydrochloric acid and sodium hydroxide. So, first step, we want to identify the ions, cations, and anions that we have in our solution mixture. So, from the hydrochloric acid, I would expect hydrogen ion and chloride ions. From the sodium hydroxide solution, I would expect sodium ion and hydroxide ions. Now, I'm going to swap the cations and anions. So sodium ion is going to combine with the chloride ion, and hydroxide ion is going to combine with the hydrogen ion. So the products are going to be sodium chloride, which is soluble in water, and H2O liquid. And the reaction is balanced. So let's look at this. The reaction of hydrochloric acid and sodium hydroxide is a double replacement reaction because we have two compounds that are reacting with each other. Now, hydrochloric acid is an acid. This is a base. From this reaction, sodium chloride is formed, which is the salt and water. Now, let's look at different types of double replacement reactions. Acid-base reactions are one type of double replacement reactions, and these are called neutralization reactions. So the products of an acid-base reaction is always going to be salt and water. So let's look at an example here. Here we see the reaction of hydrochloric acid and sodium hydroxide. In order to complete this reaction, this is a double replacement reaction, so let's write the ions we expect to get from each solution. We expect hydrogen ion and chloride ion, and from the sodium hydroxide solution, we expect sodium ion and hydroxide ion. Now I'm going to swap the cations and anions. So sodium ion is going to combine with the chloride ion, and hydrogen ion is going to combine with the hydroxide ion. So I would expect sodium chloride, which is soluble in water, and H2O. Now, these neutralization reactions, acid-base reactions, are exothermic reactions. So once the acid reacts with a base, you would expect the heat to be released from these reactions. Now, looking at it differently, HCl is your acid, sodium hydroxide is a base, sodium chloride is salt, and water. So the products of an acid-base reaction are going to be salt and water, and these are exothermic reactions. Now let's look at another neutralization reaction. Here we have the reaction of sulfuric acid and barium hydroxide. To complete this reaction, I'm going to write the ions that I expect from each one of these solutions. So from sulfuric acid solution, you expect hydrogen ions and sulfate ions. From the barium hydroxide solution, you expect barium ions and hydroxide ions. So swapping cations and anions, I would expect barium sulfate as one of my products, which is insoluble in water, and H2O. And in order for this reaction to be balanced, we're going to need to have two H2O here. Now, let's look at this. Sulfuric acid obviously is an acid. Barium hydroxide is a base. And from this reaction, barium sulfate is produced, which is a salt and water. So the products of acid-base reactions are always salt and water. Now, metal oxides reacts with acid, and that's another type of a double replacement reaction. So let's look at an example and see what the products of double replacement reactions of metal oxide and acids are going to be. So we can look at the reaction of sodium oxide and hydrochloric acid. So again, this is a double displacement reaction. I'm going to identify my cations and anions, and once I know what ions are available, then I'm going to swap the cations and anions. So from here, I would expect to get sodium chloride, which is soluble in water, and H2O. Now let's look at this. Sodium oxide is a metal oxide. It's reacting with an acid. The product is salt and water. Now these reactions are also exothermic, so you would expect heat to be released from a reaction of metal oxide and acids. Last type of double replacement reactions are precipitation reactions. When two aqueous solutions react, if a solid is formed from that reaction, that solid is called a precipitate. So any formation of a solid in chemistry is called a precipitation, and a solid product is called a precipitate. So let's look at this reaction here, the reaction of barium chloride and sodium sulfate. That reaction is also shown in the picture here. So barium chloride and sodium sulfate double displacement reaction. So I would expect barium ions and chloride ions from barium chloride solution, and I would expect sodium ions and sulfate ions from the sodium sulfate solution. Now I'm going to swap the cations and anions to write my product. So I would expect barium sulfate, which is not soluble in water, and sodium chloride. Now, the picture here shows the reaction of barium chloride and sodium sulfate. So as you see, as soon as these two solutions are mixed, a white precipitate is formed. that white precipitate is barium sulfate. So this is called a precipitation reaction. Let's look at more examples for double displacement reactions. You want to know what are the likely products of the reaction of sodium sulfide with iron 3 chloride. So let's write the reaction. So we want the reaction of sodium sulfide and iron 3 chloride. So from this reaction, let's first identify our ions. We expect sodium ion and sulfide ion. And from the iron 3 chloride solution, we expect iron 3 ions and chloride ions. So swapping the cations and anions, I would expect sodium chloride and iron 3 sulfide. So iron 3 sulfide, the solubility is very low, so this is basically considered insoluble in water. We also gotta make sure that this reaction is balanced. So 2 sodium chloride. So we also gotta make sure that this reaction is balanced. So we need 6 of this, 2 of iron 3 chloride, and 3 of sodium sulfide. So let's look at another example. You want to know what are the likely products of a reaction of copper 2 oxide with nitric acid. So we're looking at a reaction of copper 2 oxide with nitric acid. So 2 compounds are reacting. I'm just going to swap the cations and anions here. So I would expect copper 2 nitrate as one of my products, and also H2O as another product. Now, if you look at this, this is a metal oxide reacting with an acid, and you would expect salt and water. And also remember that the reaction of metal oxides with acids are exothermic.